The tail monadic verb. It's a monadic verb with infinite rank that returns the last item of its argument. But what exactly does this mean? Well, monadic verbs have one argument. That is what makes them monadic. Infinite rank verbs look at the whole of that argument, and tail returns the last item of that argument. We can think of this like it's a two-step process. The first step would be using the take dyadic verb. Now the -1 means we're going to take the last item of the argument y, we're going to make it into a one-item list. But we don't actually want a one-item list, we actually want that last item. So to do that, we take the result and we use the from dyadic verb to grab that first item. So effectively, we're grabbing the first item of a one-item list that is the last item of the argument. May not make a whole lot of sense right now, so let's take a look at some examples. Let's start off with rank 3 arrays, and here we have a shape of 2, 2, 4, and it's comprised of two items, which are 2 by 4 tables. Tail is going to give us the last item. It's going to do that by making that into a one-item shape. So the shape 2, 2, 4 is going to change to 1, 2, 4. Then we're going to take the first item of 1, 2, 4, and that gives us a 2, 4 shape. Moving on to rank 2 arrays, and these are literal arrays. We have shape 3, 4. We have 3 items, which are rows. We want the last item, that's what tail's going to give us. It's going to change it into a shape 1, 4. And we're going to take the first item of this shape 1, 4, and it's going to give us a shape 4. Moving on to atoms, they're a little bit different, and that's because they have an empty shape and they have only one item, and that's the atom itself. So if I take that last item, then I'm going to make it into a one-item list, and then from that one-item list I'll take the first item, and that gives me an empty atom as the shape. Now let's take a look and see how tail deals with empty arguments. Here we've got shape 0. That means we have no items. We want the last item, so tail uses a fill in order to do this. It's a type integer, so the fill will be a 0. If the type had been a literal, then the fill would be an empty blank. If the type had been a box structure of some type, then the fill would be an empty box. But we're using integers, so the fill is 0. It's going to go into a shape of 0. When we fill a shape of 0, we end up with a shape of 1. We take the first item of that shape of 1, we end up with an empty shape, or an atom. The value of it will be 0. Moving on to rank 2, we again have a shape of 0, 2, no items. That means we're going to use a fill, but in this case, the fill will end up with a shape of 1, 2. 2 zeros there. Taking the first item of a one-item list of the 2 zeros, we'll end up with a shape of 2. If we transpose those dimensions, we get in a different situation. We have a shape of 2, 0. We have 2 rows. We have 2 items. Because we have 2 items, we are going to take the last item. That's what tail does. That gives us a shape of 1, 0. And then we take the first item of that last item, and that gives us a shape of 0, which will be a blank line. Moving on to rank 3, we have a shape 0, 2, 2, no items. We use a fill. The shape of that fill will be 2, 2. It will end up with a shape of 1, 2, 2. And then we take the first item of that 1, 2, 2 shape, and that gives us a shape of 2, 2. That's the tail monadic verb. It's a monadic verb with infinite rank that returns the last item of its argument. Hopefully, after seeing these examples, you'll have a better sense of how to use the tail monadic verb.